Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in this series, Advanced Development in Grasshopper, where I would like to take a closer look at how to handle data structures when we are developing native plugins in Grasshopper. Because as you already know from previous videos, Grasshopper allows you to work with individual points of data. So for example, you can right click here and say I want item access, so one element at a time, or you can work with lists as an input so that you can take a look at the full list of elements that are coming in. But also, as you already know as well, Grasshopper has this particular data structure called DataTrees, which is basically a collection of lists within other lists and with some additional metadata such as the name of the branch that those lists are contained. This is very handy for many operations, and we have seen in previous videos how to, using C# scripting, how to work with lists and to work with data trees. There will be a card popping up, hopefully, in the corner, pointing to previous videos where we have seen that. So in this video, I would like to take a look at how to handle lists and how to handle data trees, especially because data trees are a little different than what they are when we do C# scripting. Okay, so for example, in the previous examples, like for example, when we were developing the divide curve component, you could see that in order to output, instead of one item at a time, to output a list of items, it was just as simple as changing the access parameter of the outputs that we had here on the output. All right, it was just as simple as that. And then keeping in mind that the only thing that we need to change when in our server instance is that in the DA element, so in the data access element, instead of using the set data method, use the set data list for the output. Okay, so what we're going to do in this video is we're going to take a look at how to take a list of data as an input, and then we're going to do an example of that, and we're going to move on to data trees. So let me show you an example of how to take lists as an input and work with those. I think what we're going to do is we're going to do an example where we're going to replicate the mass addition component. The mass addition component is a component that takes a list of numbers and then adds them all together, creating the result of all the numbers together. And then it also gives you partial results of those additions. Okay? So let's take a look. Let's write the basics of a mass addition component natively. As we've done before, what I'm going to do is I'm going to go to utility components and add a new item that is going to be a subset of the template empty grasshopper, and I'm going to call this mass addition component. All right, and then a mass addition component, and this is going to be mass add, and then this is going to be mass addition without the component, and then the description adds a collection, adds a list of numbers, and then the category is going to be utilities, correct? That's what we, no, the category was pipcamp and the subcategory was utilities. All right, you need to keep this in mind. I keep forgetting all the time. So in the input parameters, what we would like to do is I would like to take a list of numbers. So this is just going to be as simple as what we did in what we did with the output, which is using the P manager object. I would like to add a number parameter. I'm going to call this numbers, and then the nickname is going to be I, just to make it similar to the native component. The description is going to be numbers to add, and then the parameter access, the only thing that I'm going to do is I'm just going to set it to list instead of an item. All right, it's just as simple as that. And then the two outputs are going to be R, which is going to be the result, and PR, which are going to be the partial results. So I'm going to say P manager add number parameter, and then R, which is going to be the result, and then the result as the description, and then this is going to be an item because from a list, when we add them all together, we just get one single number. And then I'm going to copy and paste this, and I'm going to say PR and this is going to be partial, and this is going to be partial results. And then this one, instead of an item, is going to be a list, because I'm going to have a list of numbers representing those partial results. So as you can see, managing inputs list is just as simple as changing the access parameter, but also remember when we do this pattern where we predefine the variables that are going to contain the input data and then we fetch it from the data access object, the only thing that we will need to do is that this, instead of being a curve or an integer, or it will have to be a list of all those values. So here, what I'm going to do is I'm going to define a list of doubles that I'm going to call values, and then I'm going to initialize to null, for example. And then what I would like to do now is I would like to say, if I did not get a data list, in this case we do not use get data, we use data list. If I could not get data list in parameter 0 and that I'm going to pass to values, then please return. All right. And I think the error that I'm getting here is that I don't need the ref keyword, because this is not a primitive value anymore. This is a list, which is a reference value, so I don't really need to do that anymore. And then that's it for taking the inputs. So now here I can just write the algorithm, and the algorithm is going to be fairly simple. So I'm going to create a value that I'm going to call partial, that I'm going to start at 0, and then I'm going to write for each loop. Do I need a regular for loop? I don't think I do. So for each double v in values, I am going to take, and I'm going to define also another list that I'm going to say this list is going to be a list of double, and that's going to be partials, and I'm going to initialize it to empty. All right. Beautiful. So what I do is for every value on the list that I'm loading, I say to partial, I want to add this value. Okay. And whatever the value of partial at that point is, I want to add it to partials, the list of, and this is a little confusing. So how about I rename that to, oh no, sorry, this is not partials, this is partial. Okay. You see, I'm already confusing myself. That was a poor choice of names. So I'm going to call this P. Okay. And then the outputs are going to be DA. I'm going to set the data, just one single element in the first output. That was the result. And I'm going to set the value of P, which at that point has all the values added together. So that's one thing. And then DA, the second one, what I'm going to do is I'm going to set a data list. We've seen this in the previous video, where I'm going to set the list of partials that I have created as I was adding the numbers together. All right. Okay, this looks to me like it should work. So I'm going to close Rhino, and then I am going to start a new, excuse me. I'm going to start a new Rhino that has my plugin loaded in. And I am going to open Grasshopper, and I guess it was the components that I had. Yes, I had components here, and in PC I had utilities, and it's not showing up. Why is it not showing up? Oh, I think I have the name, I have it wrong, for example, for some reason. So, but let me just say mass addition. So for example, let me plug in here the series, all right? And then you can see that value cannot be null. What is going? Parameter list is a null reference. Get data list can only be called with a constructed list T. Interesting. It looks like maybe by doing null, it's not working. I cannot assign that data to this data, to a non-initialized. Let me say that again. I cannot assign a list to a non-initialized list. I didn't know that, or I didn't remember. Utilities. Okay, so that was the typo. Utilities. So maybe then let me just initialize this to a new list that is empty. and let's see if that solves the problem. I'm going to initialize this. I'm going to open Grasshopper again, and then I'm going to open components, and then you can see that now this works. So as this is working right now, I'm going to copy partial here, and you can see the partial results, and then you can see the full result is here. So that would be 75, and this is the result. And let me compare that with mass addition, and let's see if that is the same. So I'm going to plug that in here, and the result is 67.5, and the partial results look also the same. Okay, so it looks like we're good. And now utilities, add numbers, mass addition. So this is here. All right, so this is looking great so far. Beautiful. So I think this is already good. So data lists, we know how to output data lists, and we know how to input data lists as well. It's just a matter of making sure that the inputs and the outputs have the right parameter access, and that we are working with native C# lists. We don't really have to do anything around this. So now let's take a look at how would we work with data trees instead of simple lists inside of native Grasshopper components. If you remember from our previous videos, data tree structures are this particular structure for data, that was redundant, that Grasshopper has, whereby you can have a structure that contains multiple lists in an ordered way with this additional metadata in the form of branches, indicating which, giving basically names to each one of the lists. We have previous videos for that. We're not going to get into that again. But if you remember, the way we did this when we were doing C# scripting is by using this particular class that is called the data tree, that allowed you to specify the type of data that the data tree was going to be holding. And then it had specific methods for adding data to particular paths or particular branches, etc., etc. So this method using the data tree class is very similar to what we're going to do inside of native Grasshopper components. But we're not going to be using data tree because the data tree class was actually designed primarily for scripting components. So if you look at the Grasshopper documentation, the SDK, you can see here implements basic Grasshopper data tree functionality. It's easy to use. It's mostly for scripting components, but if you're using the Grasshopper SDK, so what we're doing ourselves, which is writing native plugins, you should consider instead using the GH structure class. If you go to the GH structure, it's basically the same thing. It's just that it contains many more methods and much more functionality that can be used. It's basically perhaps like a superstructure or like a lower level structure. I'm not sure which one to call it, but it basically has more stuff and more refined access to many things. It just requires a little bit of management from our side, but that's fine because we're at a level where we can handle that management, and we actually want that management so that we can have fine control over what we're doing. So the only difference will be that instead of doing things the way we did them with the data tree class, instead of that, we will be using the Grasshopper structure class in a very, very similar way with a few minor changes. So why don't we go ahead and we try to replicate this component, the point grid. What I'm going to do is I'm going to copy this whole thing so that we have it as a template to look at. All right. And I'm going to close Rhino and everything. And I'm going to create inside of vectors, I'm going to create a new component that I'm going to call point grid component. All right. And before I lose my stuff from the clipboard, I'm just going to paste everything. It's not going to work. I just want to have it there for reference so that we can look at it when we get there. All right. So the name of the component is going to be point grid. The nickname is going to be point grid. For example, the description creates grid of points. For example, the category is going to be pcamp, and the subcategory is going to be vectors. I forget construct vector. Yes, vector. The subcategory is going to be vector. All right. Let me take a look. Oh, I forget what the input parameters were. So I would assume that it would be something of the kind, the number of elements in the y direction, the number of elements in the x direction, the gap in the d direction, and the gap in the y direction, and the starting point, perhaps, as a point. All right. So let's start with that. So I'm going to say pmanager.add, I'm going to add a point parameter, and I'm going to call that s, no, sorry, the start, and then s as the nickname, and then starting point, and then this is going to be an item. So I just want one point to start working with. Then pmanager add point, I'm going to add a number that is going to be an integer, because I'm going to say how many elements in the x direction and how many elements in the y direction. I'm going to call this count x, and then number in the x direction, number in elements in x, for example, and then the Grasshopper parameter access is going to be also of the type item. So now I'm going to copy and paste, and now it's going to be in the y direction. Okay. And then the next one I'm going to do is pmanager. Pmanager, this is a little tedious. Pmanager.add numbers, and then this is going to be a step in the x direction. All right, and we were calling that, what were we calling this? dx. So we're going to call this dx, and then distance in x, for example, and item. And then step in the y direction, dy and dy. Okay, beautiful. And I believe that the output is going to be just a collection of points. I forget if we had something else. We can take a look at that later. But remember, so I'm going to add points, and this is going to be p. The name is going to be the points, and then the nickname is going to be p, and then grid of points. And then parameter access, the only thing that we need to keep in mind now is that what we want is to output a tree of points, because remember, for this grid, what we're going to do is we're going to have one branch for each row of points that we are designing here. Okay, so I'm going to do 3 here. Beautiful. And then just to be consistent with what we did before, I'm going to keep S, capital S, dy, and x and y as the names of the variables. So I'm going to start and say double dx equals 0, double dy equals 0, 0.3d s is going to be a point that has not been defined, so it's going to be unset, and integer number in the x direction is going to be 0, and number in the y direction is going to be 0. And then if da dot get data for parameters 0 and reference x, if this didn't work, then return. And then I'm going to do that for number 1, and that's going to be an x. I'm going to do that for number 2, which is ny. I'm going to do that for number 3, which is dx, and I'm going to do that for number 4, which is dy. All right, beautiful. So at this point, I have all my data correctly loaded and available for me. So what I would like to do now is I would like to basically be able to create a similar algorithm to the one that I have here. So how does this work? Well, it turns out that instead of using DataTree, as I said, what we can do is we can use the Grasshopper tree structure. So what I'm going to do is I'm going to type Grasshopper underscore structure. Is that? Yes. And you can see that I am not getting an autocomplete for this class, which is strange. Why is that? Well, if we look at the Grasshopper Grasshopper structure class, you can see that it belongs to the Grasshopper kernel.data namespace. And if you think about it, if you look closely up here, we do have the Grasshopper kernel namespace, but we don't have the sub namespace loaded in there. So something what we can do is we can say, well, we have the Grasshopper kernel.data. So we have the Grasshopper kernel available. So what we could do is we could just write data dot and then Grasshopper underscore structure, but that's actually not working for me. I'm not sure why. So what I can do instead is probably the easiest way is just say, well, I want to use also grasshopper.kernel.data. All right. And then once I do that, now I will probably have available here my Grasshopper structure. And then inside of the square brackets, I will need to define what type of data I'm going to take. I will get to that in a second. So I'm going to say, I'm going to define this, is going to be points, and I'm going to create a new data structure that is going to be empty. Okay? Now here I get the T parameter as a default. To mimic what we did before, I could say, let me say that I want point3D to be the class or the type that this Grasshopper structure is going to hold. However, we have a problem there. And the problem is that Grasshopper structure as a class is actually very specific about the types of data that it can take. And it turns out that because Grasshopper types, because Grasshopper components actually do a lot of processing of native types into custom Grasshopper types that then have all this additional information that helps them know how to convert themselves into data that can be transferred through a wire, or convert themselves into data that can be serialized and saved into a file, etc., etc. It turns out that the Grasshopper structure doesn't accept plain RhinoCommon data types, just like point3D is. If you look at point3D, you can see that it's coming from the rhino.geometry namespace, whereas Grasshopper structure is coming from the Grasshopper namespace. So there's a mismatch there. And if you look at documentation, point3D cannot be used as a parameter, blah, 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 because there is no boxing conversion to the subtype I interface Grasshopper Go. This is a really weird This is a really weird way to say that the type that you need to use here cannot be a RhinoCommon type. It has to be some kind of point type that belongs to the Grasshopper SDK. And the way that we're going to do that is that we're going to use the Grasshopper type, which is, let me actually look that up, Grasshopper point, and see where that is. Grasshopper point is inside of Grasshopper kernel and types. So what you can see here is that Grasshopper gives us wrappers around primitive RhinoCommon types where Grasshopper adds all this additional information that it needs for data to flow correctly between components, to show up in an output, in an input, etc., etc. And you can see that there's actually wrappers for everything. There's actually wrappers for circles, B-reps, curves, but also even for primitives. We have wrappers for an integer, for a number, for simple points, for a lot of stuff. So what this means is that whenever we want to create data trees of a particular RhinoCommon type, we will have to find the matching Grasshopper type inside of the kernel types namespace. So for example, if I write here Grasshopper point, you can see that it's also not showing up, and that is not showing up because that belongs to the Grasshopper kernel types namespace. And as I do that, you can see that now this shows up, and now this shows up, and now I can store these points in my Grasshopper structure. So with that, we are good. And actually, most of the rest of the algorithm should work pretty similarly. So if I uncomment this, you could see that for the most part, everything is working well. So I can do my for loop, my computation, I can create a path, etc., etc. I can create my point3D. The only problem is that I cannot add, I'm getting an error when adding this point that I just created to the Grasshopper structure. This is because, again, it's a problem with types. What I'm trying to do is I'm trying to add a point 3D, remember this is coming from RhinoCommon, to a structure that is designed to contain Grasshopper points coming from the Grasshopper SDK. And the problem is that Rhino doesn't have an automatic way of converting from Grasshopper point 3, sorry, from Rhino point 3D to the native Grasshopper point. So how can we do that? Well, if you look at the Grasshopper point, if you not number, if you look at the Grasshopper point class, you can see that in the constructors you can create empty Grasshopper, blah blah blah, empty Grasshopper points. You can see that interestingly there is no component that there's no constructor that allows you to create a Grasshopper points from XYZ coordinates. This is a very clear indication that this class is not actually meant to be a class to work with or to operate with points. It's a class that is meant to wrap native RhinoCommon types and then just add a lot of metadata and additional information. So actually, what I can do is I can initialize a new Grasshopper point with a RhinoCommon point, which is what I'm about to do here. So what I can do is I could say Grasshopper, I'm going to say Grasshopper dot point JHP is going to be equal to a new Grasshopper point from P. All right. And then this is the one that I could feed into my into my Grasshopper data structure. Okay. And what else? This is not working because points doesn't contain a definition for adding. This error is caused by the fact that if we look at the documentation of the Grasshopper structure, it turns out that it doesn't have on its methods, it doesn't have an add method, just like lists do. It has this method called append, which does a very similar thing. It just adds whatever type to the tree and with optionally a path to target where that object should go. So it's just basically a semantics problem. I wonder if David Rotten, when he was designing this, he thought that having add as a name would be confusing between DataTrees and lists. So he decided to change the name to append to make sure that people were aware that this is not a list anymore, that this is a data tree. So I can append, and then I can append my Grasshopper point object. And let me see how, if I were trying to append the point 3D object, I would not be able to do it. I need to be the Grasshopper point object, all right, to this particular path. Or if I wanted to be perhaps a little more quick or elegant or fast, I could just bypass that, directly creating that, that variable and just create simply a Grasshopper point on the fly as I add it to the tree. And literally this is it. That's everything that we need to take care of when it comes to data trees inside of native Grasshopper components. The idea that we don't use data trees and the idea that we need to find the corresponding Grasshopper type that we can use to wrap the native RhinoCommon type that we will typically be working with. So now what I can do is I am ready for generating the outputs here. So let me say that da.set data tree as an output, so this is a new one, on position 0, and that the tree that I want to set out is going to be PTS. All right. Beautiful. Where was this going to go? It was going to go into vectors. So let's see if this works. What do you think? Is it going to work? Is it going to work? Let's give it a try. Okay, my Grasshopper went on the other screen, and then here now under vectors I have point grid, and let me open the other file. I'm just going to copy literally the other file, the data from the other component. Oh, and it crashed. I've been having this problem before where when I'm developing, I can't really open other files. That's kind of sad. So let's just replicate it manually. Give me a second. Beautiful. So here we are. This is the point grid component we just developed. I plugged in a point. I plugged in a bunch of numbers to control how many elements in one direction or the other. It looks like if I turn the pre-visualization on, this is working. I can control the direction in the gap in each one of the directions. But most importantly, is this a data tree? So beautifully, what you can see is that what I'm getting out of this component now is this list of lists where I can have now, for example, I have 10 lists with 2 points each one of them structured as a data tree with different branches, etc., etc. Okay, so beautiful. That was it. So this is this is all basically that you need to know about working with data trees inside of native components. All right, you can create empty data trees like this. You have to make sure that you wrap the data tree, the data inside of proper Grasshopper types, and you just have to output it with the set data tree method and make sure that the output has the correct parameter access as the tree. Okay, and similarly, if we wanted to work with data trees that come into the component, it would be very, very similar. So let's take a look at a very quick example of how to do that. So for instance, let's say that we wanted to replicate now the tree info component that we developed before. If you remember, it's just a component that takes any tree, a tree that is generic. It doesn't have to have a type because it's going to just fetch metadata from that tree, and then it does a little bit of like going through the branches and creating some sentences, etc., so that it can output some information about the topology of the tree, how many branches contain how many elements, the paths, and then how many branches the tree has and how many items are in total in that tree. So what I've done is I've gone offline and I have started this. I created a data components folder, and inside of it I created a Grasshopper component called tree info. I added the metadata, and then what I did was, and this is interesting, is that for the input I did take an input of the type of the parameter access tree so that I can actually get the full tree with all the information. But in this case, instead of adding a point, a number, a curve, whatever, I use this generic input, which means that we don't really care about the type of what's coming into the tree. We actually, into the input, we actually care that what is coming in has to have the structure of a tree. That's only what's important for us right now. Generic is the type that we use for things that may have any type, and that us in the solver will be the ones who will handle which type that is, if we actually care about that. And then in the outputs, if you remember, I have added text for topology, text for parameters. Some of them are items, some of them are lists, integers, etc. And I've added an output of the type path, because path is a Grasshopper type that is also quite important. All right. And then I have copy pasted here the algorithm that we had in the C# script component. So what I'm going to do is I'm going to do what we usually do, which is, first of all, I'm going to fetch the data from the input. In order to do that, I have to predefine a data tree that I'm going to use to take that input data and put it in there. So I'm going to define a variable called Grasshopper structure of some type, and I'm going to call this capital T just to be consistent with the code that we wrote before. And this is going to be a new Grasshopper structure of some type. All right. Similarly to the problem that we had before, because we want a generic type, we don't care if this is points, vectors, whatever. I might be inclined to say, maybe I can just use the generic object type as a placeholder for any type of information. Okay? But it doesn't work because, again, the Grasshopper structure class requires that whatever data it implements, it has to have some additional things that are not part of the object class. So that's why when we were looking at the wrappers, so for example, if we were looking at Grasshopper point, if we were looking at the kernel types, you can see that All of these are the wrappers that were designed for taking RhinoCommon objects and wrapping them for Grasshopper. However, there is no Grasshopper object wrapper. Actually, there is a Grasshopper object wrapper. I had no idea that this was the case. I just literally discovered this right now. But what I wanted to go to is that instead of using one of these types, a technique that we can use is if we look at the types, for example, integer, we can see that integer actually inherits from this thing called the Grasshopper GUI. Or if we go to, for example, point, we can also see that this thing is also coming from some kind of geometry GUI, IGH, etc., etc. These were probably not great examples, but I guess what I wanted to say is that most of Grasshopper native data types, they all inherit or they all implement this other interface that is called the iGrasshopper GUI, which is an interface that is designed for Grasshopper data types to implement a set of functions that they need to work in Grasshopper components. What this means is that every single Grasshopper type implements the Grasshopper GUI interface. And because that's the case, the Grasshopper interface is kind of a common structure shared among all data types. So in a way, we can use that as a substitute for a generic type that is a placeholder for all possible Grasshopper types. So what I can do here is I can say, well, instead of object, let me just make sure that whatever you store here has to be something that implements this interface. And then all of a sudden that becomes a generic type in the Grasshopper subworld, if you will. The next thing that I'm going to do is I'm going to use the typical if da.get DataTree in this case. If I didn't get the input from 0, that I'm going to store in the parameter t using the out keyword, then please return. I don't want to keep executing this. Okay? Beautiful. And then after that, the algorithm is actually going to be pretty similar with a couple of changes. First of all, it turns out that the Grasshopper structure class doesn't have a branch count property. What it does have though is that if I go to d.t and I type branches, it does have a list of branches that I can then access, for which I can access the amount of elements that it has. So instead of being one property, it's kind of a property that is hidden behind another property. All right. So I can access the list of branches, and from that list, I can get how many they have with the count parameter. And then here, I am having the similar problem that I was having here before. Because branches is taking a list, is returning a list of Grasshopper GUI interface objects, those cannot be converted immediately to object. So what I need to do here is I can say, well, this has to be now an interface Grasshopper GUI object, and everything else is just the same. And then for the outputs, the only thing that I need to do is just change these, which are, if you remember, our typical outputs, and then change them to something that looks like this. So set the data in 0 to t topology description, the sentences, the paths, and similarly, I don't have branch count, I have branches dot count. Okay? And if I run this and I execute my plugin, so let me run the whole thing, we should probably be on a good track. Let me see if that is true. I'm going to open the components file that I've been using to debug, okay? And then you can see that I already placed here so I have this one, and I already placed here an example from that I did offline, and you can see that this component is now giving me, for this branch, the one with the grid points from before, it's now giving me the topology, is giving me a description of how many elements each branch has, all the paths, the amount of items, and the amount of branches and the amount of items in the tree. So beautiful. this was an example of how to use the Grasshopper tree as data structure as an input. Remember, the only things that you need to remember is at the inputs to use the tree parameter access, and then make sure that you use the Grasshopper structure class as we've done before. And if your tree has to be of a particular type, like a tree of points or a tree of curves, then you're good by just using the Grasshopper point, the Grasshopper curve class. But it is just generic because you're going to be working with the tree in general. The the Grasshopper GUI interface can be a good solution as this big bucket where to place your stuff. Okay. Beautiful. And with that, I believe this is what I wanted to cover in this video, which ended up being a little longer than I thought, but I also hope that through this you have gained some insight into more advanced development techniques, the relationship between classes, interfaces, inheritance, and also a new way of understanding how data trees work inside of Grasshopper. Okay, so we're gonna leave it there for this video. Thank you very much for being here. If you liked what you saw and if you learned something, then maybe hit some likes, subscribe to the channel, all those things, etc., etc. And let's move on this playlist, Advanced Development in Grasshopper, to the next video, which at this point, I'm not sure what it is, but we're probably going to find out in the next video. Thank you very much. Bye-bye.